green clip this sucker right there so we can write on it. Nice. So we're doing a comparison here of a veto of 69 million versus a budget of 77 billion, and we're asked to pick which sentence best fits the relationship between those two numbers. Whenever we do a comparison in math and life outside of math, it's usually either a division comparison or a subtraction comparison. That's generally the way we compare two numbers. So compare by subtracting, subtraction, or division. And sometimes we use a combination of subtraction and division. So it just kind of depends. So ideas of like percent increase versus the amount of increase. Okay, like let's suppose I get a $10 raise. Is that a big deal? It depends on what it was out of. Was it $10 an hour? Was it just 10 bucks total? So, you know, maybe I make 100 bucks a day, I get a $10 raise. That's 10%, right? Okay, so the amount, that's a subtraction kind of thing or an addition versus a comparison by division, that's a percentage. So when we compare about with division, we generally involve percentages. So I'm just going to write out 69 million and I'm going to write out 77 billion in a couple of different ways. So 69 and then million, how many zeros is that? That's thousands. That's 69 million, right? Like so. And then 77 billion. That's right. Let's see. 1, 2, 3. 1, 2, 3. To get to billion, I need another 1, 2, 3, right? And then I get the 77. Ones, thousands, millions, billions. Yep, that looks good. You with me? All right. So then, one thing I love about dividing numbers with a bunch of zeros in it, each zero represents a multiple of 10. 10 divided by 10 cancels. So I get to cross out a bunch of crap here, which is nice. So all that goes and all that cancels out. So that division is the same thing as taking 69 divided by, how much is that, 77,000? Yeah, so whip out a calculator if you got one. I'm going to grab my Google calculator. I'll do it in a couple of different ways. Google calculator, here we are. All right, so I'm playing with lesson 1.2. Good idea to label stuff. And what do I have? I have some kind of veto, and then I have a budget. Budget on a good day. 69, 1, 2, 3, 1, 2, 3, and 77, 1, 2, 3, 4, 5, 6, 79. And then I could divide them. So on a spreadsheet, remember when we want to do a calculation, we do equals, and then we point, click, divide, click. Does the order I divide them matter? I get a different answer, right? Otherwise, and they're related, but it's a strange relationship. Ooh, I get a little tiny number there. Okay, and so the other thing I was comparing to is I had 69 versus 77, 1, 2, 3. And just see if they come out to be the same thing. Extra equals will screw things up. And it looks like exactly the same number, doesn't it? Same number. Okay, let's see. That's tenths, right? Hundredths. So if there was a 1 right here, that would be 1%, right? 1 out of 100. So this is less than 1/10 of a percent. It's 100th of a percent. Okay. So having a hard time wrapping my mind around that. I'm going to switch the division just for fun. So I'm going to divide backwards. So let's see. What could I round this up to be? What would you call it if I rounded it up right here? 1. This one day. Let's see, 10th, 100, 1, it's about 1,000th. If I rounded right here, you with me? Okay, so he's vetoing about 1,000th part of the budget. Is that a lot? 1,000th of the budget, that's pretty little. Other way I could go is the budget is how many times bigger? About 1,000 times bigger, yeah. So when I switch the division, it should state that. So I'm going to switch the division just to see what happens. So what if I go equals this divided by that? And then, yeah, it's about 1,000, right? So yeah, so when you switch the division, you just kind of reverse the multiplication. You get 1,000 versus 1,000th, okay? And you can talk about it either way. So I'm going to write 2 sentences comparing these. And you guys help me figure out if I get it right after. So he's going to veto part of it, okay. So Scott, oops, that's not right in red, looks like we're angry. Scott vetoed about oops, I was going to use words, about type numbers, 1,000th, I think I spelled that right, 1,000th of the $77 billion budget. Budget. Does that look like did I state it accurately? The veto part is smaller, right? So the veto is the smaller part of the budget. So that's one way I can make that statement there. I could switch it the other way. So if I did it the other way, I would state the budget first. So let's see, the budget is 1,000 times, oops, supposed to use words, not digits, darn it. Those digits are so much more convenient, don't you guys agree? The budget is 1,000 and 1,000, yep, times greater than the amount vetoed. Does that seem like reasonable, proper language here? Vetoed. Did I reverse it right? Yeah, so notice when I do the comparison, I got to change the, and if I change the multiplication factor, I got to change the order of the two things happening. Right? So just always ask yourself, did I get these guys in the right order? See if it makes sense when you do that. So here, the smaller thing went first, so then I have the fractional comparison. Over here, the bigger thing went first, and so then I have the big number comparison. Okay. Is there a sentence there that kind of fits one of those statements? Portion vetoed is a very small part of the entire state budget. Yeah, that's true. Okay, 69 million is about 1,000th of 77 billion. Is that true too? That's true too, I think. 69 million vetoed is a very small part of the entire state budget. Yeah. The 69 million that was vetoed is about 1/10 of 1%. Ooh, I have to think about that for a minute. 1/10 of 1% of the total $77 billion budget. That one is more complete if 1/10 of 1% is correct, because that includes all the information. So is 1/10 of 1% correct? Let's check that out. 1/10 of 1%. Usually when I see of in math, it means multiply. Okay. Or I think I could write that, like what's 1/10 as a decimal? 0.1. I got a weird extra symbol in there. Okay, so that's 1/10 of a percent in blue. It's same thing in black. I just wrote it 2 different ways. How do we change percent to a regular number? What's that? Almost. Other way, switch it. Divide, yeah, because remember, this symbol right there, oops, I didn't want the eraser. That means divide, the 2 zeros mean 100. So I can literally replace that with the 0.1 divided by 100. Or if you like the fraction notation, 0.1 over 100. And dividing by 100 has to make this smaller, which means the decimal has to go to the left. How many places to the left? 2 places. So then I usually draw that in, jump once, jump again. So in my answer, I'm going to have a 0.001. I usually like to put a 0 in front. It makes me feel better. It makes me realize that's not just a splotch on my paper, that it's the decimal point. Tenths, hundredths, thousandth. So is a tenth of a percent the same thing as the 1,000th we found? Answer, yeah, it's the same thing. Okay. And this is warming us up for the next unit. We're going to compare on smaller numbers. Ooh, bonus question here. How would I write this sucker right there using exponents? We kind of went over this on the first or second day of class, briefly. Yeah. Negative exponents, yeah. So what you do is you look at this and say, okay, there's 1, 2, 3 places. So that should be 10 to the negative third. Does anybody remember what I said literally a negative exponent means in math last week? Flip the base, yeah. So new page. So 10 to the negative 3 means 1 over 10 to the third. What's 10 to the third as a regular number? 10 times 10 times 10, right? Or 1,000. Yeah, so there's my 1,000th right back at me. So we're just kind of getting used to how exponents play out with numbers and thousands and thousands. All right, so I think we beat that problem. Yeah, man. All right, let's see. Was there something else? Yes. Let's take a look at the next one. So hopefully everybody answered this next part on the worksheet. So D is the best answer because it has the most complete information. And they said best here. All of these are right. There's nothing wrong with them. They're just all a little incomplete given the information we have. All right. So in part 6 here, you're asked to compare 470 billion to 47 billion. So how can I make that comparison? Give me 2 numbers I could use in the comparison. What's that? So just kind of like we did the previous problem, I could say one number is blank times bigger or one number is blank times smaller. Okay, so that's a comparison by subtraction, and that works fine. Yeah. 10 times more? Yeah, so I could say the Medicare budget is 10 times more than the international affairs budget. Cool. Are you going to say something different or same thing?
I said it's 10% of what the Medicaid budget.
Yeah, so I could go the other way too. I could say it's 10%, and when we break down 10%, we get another comparison. So let's see, that way, new page. So we're comparing 47 billion to 471 billion. And Colt said the 47 billion is 10% of the 471 billion, roughly. 10% is 10 divided by 100, which reduces down to what fraction? 1/10, which is the flip, the reciprocal of what Robert said, because he went the other way and said it was 10, the Medicare was 10 times bigger than international affairs. Colt went the other way and said, oh, yeah, medical affairs is 1/10 of. And they both mean the same thing. You can take it either direction depending on what you're trying to show to somebody else. Either one's wrong, either one's deceptive. They're both just 2 different ways to do it. Cool. All right. So I hope that helps. And so there's nothing wrong with you doing the subtraction comparison, but kind of based on the statements above, we were looking more like a multiplication division kind of comparison. All right. And then you were asked to say, okay, we have our $680 billion deficit in 2013. Remember, a deficit is what we overspent in 1 year. The debt is the accumulation of a bunch of those that we haven't paid off yet. Let's see. And so you're just supposed to pick one of these and compare them. Like median household income. So median means kind of in the middle. So on average, in 2013, if you grab the family, they make about $60,000 a year. Okay? And then I want to see, well, how many times bigger is 680 billion? So I could plug that into my calculator. If I want to do the billion comparison, then I got to plug that in the big number in first. So we have 2013 deficits of 680 billion, 680, 1, 2, 3, 1, 2, 3, 1, 2, 3, is that right? That takes me thousands. I know, we need those commas, don't we? 1, 2, 3 millions, 1, 2, 3 billions. Yeah, I'm pretty sure that's right. But like Colt said, let's put those commas in. Or, oops, I gotta zoom out so I can see the tools. Ones, thousands, millions, billions. Yep, we got it. Versus household income. And remember, get in the habit of labeling stuff right away, otherwise you'll be like me and forget. And then I'm going to divide the two of those. And this is something we can totally do without a calculator because we get to slash a bunch of zeros, which is always kind of fun. But calculators are also fun too. Oh my gosh, that's a big number. Whoa, I knew it was going to be big, but that kind of took me by surprise there. What would we say? How many times bigger, roughly? About 11 million. Yeah, so I could dip some decimals there. But me zooming in and out isn't making anybody dizzy. Right. That's about 11 million times. So the deficit in 2013 is 11 million times greater than the average household income. Let's see, how many families do you think there are in the US? Let's make a wild guess. Anybody remember about how many people are in the US? 300 million-ish. Let's just double check. Let's search for US population. And yeah, about 323 million right now. So it's a little more than I said, 300 million, I was rounding. So average family has what, like 4 people in it maybe? Something like that. Some people have more, some people less. So if I take that number, divide by 4, I'll get a rough estimate of the number of families. So US people, about 323 million. 1, 2, 3, 4, 5, 6. Right? So US families, that divided by 4. Need some commas there, don't we? There's about I think it dropped. It's more like 2.1 kids per family. Yeah, so people have 2 kids and then this other, maybe it's the dog. Number.
I figured it would be lower because
yeah,
half the family only have 1 parent now.
Yeah, so that's a good question. I bet the US Census has data on that from 2000. The last one was 2010. I'll have to look. I'm going to make a note to look that up. US family size. Yeah, the idea of families is interesting. It changes over time. We can look that up later. So it looks like, there's roughly 80 million families in the US, roughly. Okay. And anyway, numbers to compare. All right, let's move on. So I would like to collect worksheet 1-2 from you today. So I'll give you some time in a little bit to finish up those last couple of sentences or calculations if you need to. For those of you who turned it in early, if I marked up any of those back statements, you can resubmit it if you want. So if you want to change that resubmit, you can totally do that. You turned it in early.
We went over 5 and you said like basically everything would fit, right?
What's that?
We went over 5, basically everything on there would fit. Because 69 billion is about 1,077 billion. And then you said D was basically the same thing, just did it backwards instead of.
Yeah, so because it's the vetoed part is 1,000th, and 1,000th is also 1/10 of 1%.
The other 2 are also correct.
They're correct, but I think D is the best one.
D is.
Yeah, and they were looking for the best statement because D takes into account both numbers, what the numbers represented, and how many times smaller or bigger the numbers are. So for example, statement A is correct, but it doesn't mention what either number is. And it uses the idea of small. What's small? You know, I don't know what the hell small is. In statement B, they state the two numbers, but they don't state what the numbers mean. What does 69 million represent? Right? If they don't state, it's the amount vetoed. And then C, again, they state at least what the numbers mean, but they go back to very small. What's small? So D is best because it states the number, what the number means, and how much different it is than the other one. So whenever we write quantitative statements, we want to be as complete as possible without writing a whole book. All right, so you can just drop it up here if you're already done. Otherwise, I'll get it from you before we part ways. We are going to take a look. Oh, there's a homework problem I want to look at in section 2. Which one is it? Number 10, maybe? No, not 10. 9. 8, 7, 6, 5. There we go. Okay. Ooh, that displays oddly. Okay, looks like I can't blow that thing up. Let me copy that into my screen. So you've all heard metric prefixes before. Things like a kilogram is a common measurement of mass that's similar kind of to a pound. And then playing with computers and phones, they talk about gigabytes of RAM, gigabytes of memory. Now, what's the new measurement of storage? Instead of giga, what are they saying more often now? Terabyte. Yeah, so if you go to like Walmart and you need to buy a backup drive, that drive is probably going to be measured in terabytes now. Whereas a few years ago, it was measured in gigabytes. And those little flash drives we carry around, they're still measured in gigabytes, but someday soon they'll be measured in terabytes. And so tera is bigger. And so just, it's a good idea to know a few of these. So the ones I think you should know, based on stuff going on in our society, on the big side, you should know what tera, giga, mega, and kilo represents.
Is tera different than
Tera is different than tetra. Tetra usually means something to do with 4. Questions. Google that. Yeah, tetra. Dictionary. Ancient Greek. Tetra technologies. Wikipedia. Several freshwater fish. Huh. Yeah, so I'm used to tetra as being 4. Like there's a 3-sided figure called a tetrahedron. I'll show you a picture of a tetrahedron. It's awfully cute. Tetrahedron. It's a pyramid with a triangular base. It's a tetrahedron. So you remember seeing tetrahedron as a metric prefix?
you were in
In computer science. I think it would have been tera, not tetra. Let's double check. Let's get more complete metric prefixes. Let's see. Try this one. See how much it has in it. Oh, here's a whole bunch. Let's blow it up so we can all read it. Oh, Yoda, Zeta, Pentatera. Yeah, I don't remember a tetra. They don't have one here. It doesn't mean it's not in existence. Notice they skip a bunch of places. They go 12, 15, 18, 21, 24. And that's kind of like where we group by 3. It tends to be more important. Yeah, I don't know. The common usage I'm used to with tetra is just to mean 4 things. Okay, whoa, that's a scary picture. Okay, sorry, I was not scary. All right, back to this sucker over here. Okay, so these are ones I want you to be familiar with. So kilo generally means 1,000 of something. Mega Like you might hear about megabytes, or like phones go by megapixels. You guys familiar with that idea, megapixels, when like they're talking about smartphone cameras? That means a million. Giga is a billion. And tera is not to be confused with tera as in Earth. Tera as in trillion. And they'll talk about, in computer stuff, terabytes and gigabytes. Just a side note, a tera isn't exactly 1 trillion. A giga isn't exactly 1 billion. It happens to be a little bit bigger. And that's just a weird thing that'll come up sometimes. So sometimes when you look up megabytes, it will say 1 million. Other time it's a slightly different number. And the catch there is, in computers, does anybody know what language computers generally function deep down inside with? Just ones and zeros, right? So computers, at their heart, only know how to deal with ones and zeros, and programmers make an interface that humans can then interact with, so they don't have to see the ones and zeros that computers do. Two things, it's called binary notation, and like in our number system is called decimal because we use base 10, right? So it's all 10 to the first, 10 to the second, 10 to the third. Computers, it's all powers of 2. So somebody whip out a calculator. What's 2 to the 10th power? Calculator nearby, computer. So yeah, you just go 2 times 2 times 2 times 2. $1,024. Yeah. Notice 1,024 is close to 1,000, but not exactly. In computers, when they talk about a kilobyte, they're actually talking about 2 to the 10th power, which is 1,024 bytes. But they usually just round it and say, it's about 1,000. Okay. Now, a million is how many thousands? 1,000 thousands, right? So, so when we talk about mega, which is the computer version of million, what they really mean is a kilobyte of kilobytes. So that means they have 2 to the 10th times 2 to the 10th. 1,000 thousand. So whip out somebody with a calculator. What's 1,024 times 1,024? Right, because this represents 1,024 and that represents 1,024. It should be a little over a million. What do you got, Jenna? You can just tell me the digits.
10.
Yeah.
48 576.
576. So can you see that's a little over a million? That's really how many bytes are in a megabyte. But if I'm just talking to somebody about megabytes, a million's an easier way to talk about it. You know, and so what happens is when we actually talk about gigas and teras, they're actually a little bit bigger than a billion and a trillion. It just depends on how you want to, ease of talking about it. Right? So in computers, a megabyte isn't exactly a million bytes, but in the metric system, a mega means exactly a million. So we have a slightly different way of using that in like scientific language versus computer language. Okay, just a little bit of trivia. If you're ever at Max Bar and Grill on trivia night, maybe this will come up and mail it and impress all your friends. Okay, other things that I want you to know. So I'd like you to eventually soon be familiar with those. So you hear tera, you think, oh, trillion. Yeah, you hear giga, you think a billion. Okay. Other ones I think are popular and good to know. On the small side, centi, milli, and nano I think are the most popular ones to know on the small side. So centi means the same thing as 1/1000th. Oh crap, 1/100th, I lied. Getting ahead of myself. Milli is 1,000th. It sounds like it should be a million, right? But it's not. Yeah. What's 1,000th? Micro is actually 1,000,000, and that's kind of sort of popular in like chemistry, but it's not that important. Nano is kind of like the new popular unit, right? Because you heard about nanotechnology, supposed to be like the wave of the future. We're going to have all kinds of little nanobots in our body rebuilding us all the time. Question, Robert?
And the same prefix for mega and million. The symbol, why is that the same?
Yeah.
It doesn't make sense.
That's a good question. I think maybe mega is supposed to be a capital M. Let's see what that other, oh, I think I deleted that other page. I think it's capital. Cute trick on, if you ever close a tab in a web browser and you want it back, Control-Shift-T will bring back tabs that you closed. Okay, and yeah, mega is supposed to be a capital M. So let's fix our notes there. Thanks for noticing. Red. Yeah, so it used to be on my browser, I'd close a tab and I'm like, oh, I gotta look through my history and find it again or search for it again, but Control-Shift-T is a nice thing. So mega is supposed to be a capital, and usually giga is a capital G. Tera is typically a capital T. Kilo, sometimes you see it as a capital K, sometimes not a big deal. The micro symbol is a weird one. It's called mu. It's a Greek letter. And it looks kind of like a blend between an M and a U. Can you see it in there? It's kind of like a script M, but it's also kind of like a U. It's called a mu, and that's micro. But nano, I think, is a better one to know, given the rage of nanotechnology. And a nano, if we count it out, tenths, hundreds, thousandths, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions. It is 1/100000th of a unit. Okay, so nano, like nanotech. Uh-oh, run out of room there. Billionth. So often nano is measured in nanometers. So think about how big a meter is. On me, a meter is about where my top of my belt is. So 1/1,000,000th of that distance. Pretty tiny, right? Electromagnetoscope. No. What do you call those things? Microscope, there we go. Electron microscope size, super small. Down to like atom size. All right, so those are popular ones. So that was in the warm-up, or the, let's see, that was in the homework for section 2. Am I lying or telling the truth, Jenna? I'm telling the truth? Okay, thank you. Sometimes I accidentally lie if I need to. All right. So we are going to play around with the worksheet next. I'm going to print that out right now for you. For those of you online, Daisy and Jose, what you need to get out is your worksheets for section 3.
I have a question about that.
Uh-huh.
So look at the remodeling the book and stuff.
Yeah.
It has about like 4 pages.
Yeah.
And some of it goes from like to 19 and others go. Which ones are we supposed to do?
Any page that asks you to do something.
Okay.
You write stuff down, you turn it in eventually. Yeah. So this one I'm hoping we'll finish by tomorrow. All right, who needs a copy? Raise your hand. 1, 2, 3, 4, 5, 6, 7, 8. Do you want a copy?
Yes.
Okay. Immigrant printer. Let's throw a staple in there. Staple, top left, copies. That was 8, wasn't it? Okay, hopefully I sent it to the right printer. So this one, in the previous stuff, we were playing around with big numbers. Here we're going to play around with small numbers. We're also going to do a little algebra and play with exponents a little bit more. So while that prints, I'm going to give you a warm-up problem. Let's see. 69,077,000,000,000. Okay. Oops, I lost my notebook. That's going to take a minute to print and staple. New page. So we had the number 69 million up here a minute ago. Okay, got that right. And we had 77 billion. And the beauty in writing all those zeros out in a division is we get to cancel a bunch of stuff. And that's always my favorite part of math, canceling stuff. Now, a million is 10 to what power? Almost. Yes, 10 to the 6. Nice. Okay. So I'm going to write that down here. So I could say that's 69 times 10 to the 6th power. Is that scientific notation? No, it's pseudo-scientific notation. I don't really care right now because I didn't want to write scientific notation. I just wanted to write a million as a power of 10, just for the heck of it. Okay. Underneath, that's 77 billion. A billion is 10 to what power? 9th. Trillion is 12th. Okay. So, and we can look up here and count. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So I'm going to call that 77 times 10 to the 9th. And then it turns out I can view these as two different problems. I can say, well, what is 69 over 77? And what is 10 to the 6th over 10 to the 9th? And just a reminder of working with fractions, when you multiply two fractions together, don't you multiply the numerators and multiply the denominators? Which gives me what I have above. So I just kind of unmultiply those. So that's a useful trick sometimes. So I unmultiply those, and there's a method to this. Now I'm going to go back to the joy I find in math, which is canceling stuff in division. How many zeros do I get to cross out here, Aaron? I have 6 in common, right? So can I just go smack, smack, and wipe out those 6 digits, those 6 zeros? Now each one of those zeros came from one of these 10s here, right? So what can I do with this 10 to the 6th? Didn't I just cross it out above? So can I just cross it out here? Yeah. How many zeros didn't I cross out? Well, I had 9, I crossed out 6, so I have how many left? 3. Okay. So what happened here was there was a little bit of subtraction that went on when I divided those exponents. Now the trick actually is a little more twisted than that, so I'm going to put this on a new page. I have 10 to the power 6, I'm dividing by 10 to the power 9th. The trick is, if the bases are the same, do I have the same base here?
Yes.
Yeah. Then I can just write down the base, the fraction goes away. Notice there is no fraction there, right? And to find the power, I just subtract numerator exponent from denominator exponent. What's 6 minus 9? -3. Okay, so now I have to deal with negative numbers. That was part of the prep last night. Hopefully you guys did. So this is equal to 10 to the -3rd. Is 10 to the -3rd have any relationship to dividing by 10 to the 3rd? They're the same thing, just two different ways to write it. Okay. And generally when you do math, there's multiple ways to think about it. Right, so I get the same result each time. Would you agree that 69 and 77 are about, they're pretty close, right? So this is kind of sort of close to 1. So my belief is when I divide these two suckers, whether I cross out zeros or I subtract exponents, don't I get about 1,000th in the end? It's just a different way to look at what we did earlier. So the trick here is, if numbers are in scientific notation or pseudo-scientific notation, it turns out I can mess with the exponents. I don't have to write it in standard form and then cross out zeros. And you're going to get some practice in that in this lesson. And I think it's done correctly. All right, so we'll get this started right now. I'm going to direct your attention to the area. All right, so let's see. I would like you to read through this thoroughly tonight. Don't worry about it at the moment. If you already had a copy, maybe you read it online. Let's scoot over to, let's skip the equation and expression stuff for now. You can try it tonight, we'll go over it tomorrow. Take a look at the 1 to 3rd page. It has a table, part of which is in gray. Catch up, lesson 3, table in gray on page 3. Yeah, there is stuff to do before this, but I'm skipping it for now. You can look at it tonight. So they tell us here, right, and we went over this in class a couple of days ago. 100 in scientific notation would be 1 times 10 to the second. 10 would be 1 times 10 to the first. What would 1 be? 1 times 10 to what power? To the 0th power. Yeah, so you're just supposed to fill in what power of 10 each of these fractional decimals is. Okay, so 1 would be 10 to the 0. How about down here? What would this last one be? 10 to what power? -4. Yeah, and you can count the places, right? 1, 2, 3, 4. That would be 10 to the -4. Okay. I'm going to just double check that by drawing it out on the board. If I can find my magic pen. Where did I put it?
Right next to the.
Ah, thank you. All right, so new page. So we're picking on 0. Oops, that's not a pen. That's not a pen either. There we go. 0.0001, is that the last number in that list? Okay, so a couple ways to think about it. If I want to I could say that's 0.0001, but that's slang. The real way to read this is say, okay, that's tenths, hundredths, thousandths. What's next? 10,000ths is next. And so that's 1 over 10,000. Okay, so there's my 10,000. 10,000 would be a 1, it's a 1 with 4 zeros, right? Or I could write that as 10 to what power? 10 to the 4th? And 1 over 10 to the 4th is 10 to what power when it's not in a fraction? -4, because that's the opposite of flipping it. So we get a negative in there, right? So there's a couple of different ways to think about that, okay? Mostly what we want to be used to is just looking at this and say, okay, 1, 2, 3, 4 places. That means it's 10 to the -4th. Okay. All right, I think we're about out of time for fun with math. There is some algebra. I'll go over the algebra in more detail tomorrow with you, but a lot of this you can do yourself. So the things I want you to try tonight for sure is just start reading through it, and in particular, pay attention to 2 pages down. Problem number 8. They give you a bunch of things like this distance from Earth to the moon, the size of a virus, and each one of those phrases, those things, can be matched with one of these powers of 10 below. So do your best tonight to try and do that, and we'll double check it with each other tomorrow. Okay? So take a look at that for sure. So read through this, get it started. If you didn't finish the prep on section 3, get it done. If you didn't finish the homework on section 2, get that done too. If you have any questions, call, email, or stop by. Have a wonderful fall day.